Okay, this is the 2005-2006 question 2 from the spring. Consider the function y equals f of x equals 1 over x minus 4 where x is not equal to 4. Essentially, it's not equal, it can't equal, the value can't equal 4. Uh, so find the y-intercept of f of x. Show that the function has no local maximum or local minimum points, and there's a few more questions there that are just out of shot there for the moment, but I'll come to them as we go. Explain why the function is decreasing for all values of x. There's a couple more questions yet, but I just want to get started on the first few. So what we have here is let's just write this out again. Y equals 1 over x minus 4, and again, just x naught can't equal 4 in this scenario. The y-intercept you let x equal to 0. Okay, so what we have here is y equals 1 over 0 minus 4. So the answer is pretty clearly to that one is 1 minus a quarter. So the y-intercept is 0 and minus a quarter. By the way, that's the proper way to state the answer there. Not just like, you don't just say y equals minus a quarter. The y-intercept is that point there, okay? And again, the trick is y-intercept, you let x equal 0 and find out what point that would be. So, but necessarily y has to equal 0. Or x has to equal 0. The next question is, I'm just going to go back there now and let's read it out again. Show that the function has no local maximum or local minimum point. So it has no turning points. Okay. So what we have, let's write out our equation again. Y over x minus 4. Now, what we're going to do is find the derivative of that, dy over dx. Okay, now do you recall the quotient rule? And that is in the form u over v, and the derivative of that is v du dx minus u dv dx all over v squared. That's how you find the derivative of a function that's written in terms of u divided by v. So here, x minus 4 is v. The derivative of u with respect to x is derivative of 1 with respect to x. So that's just 0. Minus u, in this case, is going to be 1. And the derivative of x minus 4 with respect to x is just 1. And that's all over x minus 4 to be squared. Okay, so x minus 4 times 0, that just goes to 0. So our answer is minus 1 over x minus 4 squared. Okay, now dy dx. Now the turning points are where the derivative of y with respect to x are equal to 0. So what you have to try and figure out, which points are equal to 0. Now it actually sort of leads you in the question, and it sort of says, show that the function has no local maximum or local minimum point, which is to say, this here should be false. Okay, so by definition, a turning point will follow this equation. Okay, but essentially there is no way that that value can equal to 0. Okay, minus 1 divided by some number, you could either have x minus 4 squared, it's always going to be a positive number, so minus 1 divided by whatever squared is always going to be minus 1 divided by a positive number. And also, just remember, I sort of said earlier on that x can't equal 4 in this particular case. So in this case, you sort of say this could minus 1 divided by x minus 4 squared. That could never equal to 0. So this actually is impossible. Okay. That it just can't happen. That's actually simply state that it's enough that is impossible. So no turning points. There is no maximum and no minimum because it's not mathematically possible. Okay, that's a very important question. Actually, that's in the exam you get about 5 marks for that. So in that particular year, explain why the function is decreasing for all values of x. Okay, we have earlier on found out that the derivative of y with respect to x is minus 1 over x minus 4 squared. Okay, and I'll just write it out again. dy over dx equals minus 1 over x minus 4 squared. Now, that's negative, minus 1, and that's always going to be positive. A square number is always going to be positive, and it also can't equal 0. You can't get we already said again, I'll just state this for x cannot equal a 4, so this x minus 4 can never equal 0. So it's a negative divided by positive is always going to be negative. Okay. So a negative divided by positive is always going to be negative. So this is always going to be negative. dy, or actually just write that in blue again. dy over dx, always negative. So that is why it is a decreasing function. The slope is always, or the slope is always negative. Okay. So essentially, that's the key thing there that you have to look for. dy over dx, it's always negative, and you're sort of led that way in the question. Explain why it is the function is decreasing for all values of x. So that's okay. So the next part of the question, I'm just going to sort of pause for a second and write it up. So the next parts are find the equation of the vertical asymptote and the horizontal asymptote. Actually the same, it's two different questions, but I just bunched them together. And finally, the last one is sketch the graph. So the first part is find the equation of the vertical asymptote. So this is actually easy enough. It's x equal to 4. The reason for that is that because the graph can never equal, or the x can never equal 4, it's just a bit of a giveaway. Let's have a look at that. So we have y equals 1 over x minus 4, x not equal to 4. Okay, so it's the vertical asymptote is this line here. So let's say this is 1, 2, 3, 4. So the graph, actually I'll just put 4 here. So that's 1, 2, 3, 4. So this is the asymptote here. And the graph sort of looks a bit like this. Well, sorry, it doesn't cross the line obviously, but okay. That is the line. Okay, so yeah, it's x equal to 4. In this case, it's just painfully obvious. It's just that the graph, which is drawn there in blue, the green lines are the x and y axis. The graph here is the blue lines there, the blue curves sort of represent y equals 1 over x minus 4. And the red dotted line is the asymptote, which is essentially a horizontal or a vertical line, vertical in this case, which will be the line that the curves approach but never touch. Okay, so it just goes on like that, down closer and closer to the asymptote, but never actually touches it. Likewise with the other one. Again, you can also sort of quickly pick out the the horizontal asymptote is going to be the x-axis, the y equals 0. But how do we know that? There's actually a proper formula for that. So that's the horizontal axis or the vertical axis. The horizontal axis is as follows. The limit as x approaches infinity of 1 over x minus 4. Okay, so that is simply 1 over infinity. Okay, just let it 1 over x minus put in infinity into x. You have 1 over infinity minus 4 correctly, which is 1 over infinity. If you think 1 over infinity minus 4 doesn't really make sense, infinity minus 4 is a bit of a silly thing to say. So we have 1 over infinity and that is equal to 0. So the y-axis, the x-axis, which is y equal to 0, is the asymptote. So the limit of as x approaches 0 of y equals 0. So it's the asymptote is y equals 0. That's the horizontal asymptote. Right. So there's a quick remark here actually about the graph. Now, essentially what you could do there is just pick out some points. For example, let's say this is the point x equals 5. So you could pick out the point that would be 1. That would be the point 1, 5, and so on. You could just pick out a few points like that. Also, you should really pick out the y-intercept, and that is the point 0 minus a quarter. Okay. What else would you sort of... The asymptote here, x equal to 4 and y equal to 0. The asymptotes. Yeah, that's it. Just as sort of a good bit of labeling on your graph as well. Just for the sake of time, I'm just sort of cutting back on that one. It's the... we'll just leave it there, actually. Okay, bye.